Hello, we are going to talk about room temperature superconductivity in a carbonaceous sulfur hydrate. The members of the team are Débora de Aces, Sergio Guajardo, Héctor López, Marta Rodríguez, Raúl Soto, and Alexa Vargas.
Hi, my name is Raúl Soto, and I'm going to talk about background. Nowadays, every day we use different objects and tools. These here are made of different materials. Each one has different properties due to its structure and composition. One of them is conductivity. Most of the conductors are metals, such as copper, silver, gold, etc. However, they do not have complete conductivity. That is why scientists have worked on superconducting materials. Advances came in the 2000s when supercomputer simulation allowed theories to predict the properties of various hydrates. The latest and most accurate advances came as in improvisation on the 2015 formula. The researchers started with hydrogen sulfide, add methane, and geared the mixture with a laser. But in 2019, a team of physicists in New York has discovered a material that conducts electricity without loss at room temperature, a scientific goal they have long pursued. Although the researchers say they will never lead to lossless power lines because the substance only behaves like a superconductor at room temperature while being crushed between a pair of diamonds to extreme pressures. Thanks.
The main objective from this research was to develop room temperature superconductive materials and introduce a new way to synthesize superconductive materials at lower pressures than the ones that were used before. You might be wondering how all of these superconductive materials were discovered. Well, in the first experiment made, the team mixed hydrogen, carbon, and sulfur to photochemically synthesize a carbonaceous sulfur hydrate. This compound led to a material with a superconductivity above 58 degrees Fahrenheit that can take over 39 million pounds per square inch of pressure. In the second experiment, hydrogen atoms were isolated from yttrium through a thin film of palladium. The superconductive materials that was made during this experiment had a superconductivity over 12 degrees Fahrenheit, and the pressures that could take were over 26 million pounds per square inch.
Hi, my name is Hector, and I must mention that the main characteristic of a superconducting material is its ability to conduct electricity with zero resistance without the need for special cooling. In addition, it is soon expected that it will not be necessary to maintain these low temperatures to maintain the material as a superconductor. The authors report that they achieved superconductivity at room temperature in a compound of sulfur, hydrogen, and carbon at a temperature of 14.4 degrees Celsius. This is 28 degrees higher than the superconductivity record in 2019. However, the exact details of why this compound works are not fully known. Researchers are not even sure of what compound they have formed exactly, but they are developing new tools to figure out what it is, and they are confident that when they do, they will be able to modify the composition so that the compound can remain superconducting at low pressures.
The researchers and authors of the paper were physicist Ranga Diaz, who is an assistant professor of mechanical engineering at the University of Rochester. Also, co-authors include lead author Elliot Snyder, all the Diaz Lab Department of Mechanicals at the University of Rochester, and also Ashkan Salamat of the University of Nevada, Las Vegas, and some others.
My name is Alexa, and I will talk about possible application for the superconducting materials. The first one is the evolution of the electrical system. Transformers, which are crucial to the electrical grid, could become smaller, cheaper, and more efficient. The second one is energy storage. They could serve as a very efficient way to store large amounts of energy for longer periods of time, making intermittent but renewable energy sources such as wind turbines and solar panels more effective. The next one is generation of powerful magnets. Can be used for many applications such as magnetic resonance machines and levitating trains. And the last one, advancement of quantum computers. This will be simple, smaller, cheaper, and promoting their development.
Hi, I'm Sergio, and it's time to talk about the challenges that still need to be overcome in relation to superconducting materials. First, we have the stability. It must be taken into account that superconducting materials are also unstable and can lose this property if there are sudden changes in current or temperature, or if there are shocks, so it is necessary that there is greater stability in this, and they can withstand possible changes in the conditions of use. That's why these materials must have high critical temperature, critical magnetic field, and critical current density. For example, as one will expect to use materials in electronic devices that have to be at pressures close to those of the center of the Earth, it must also be easy to manufacture, with materials that are easily found, as a superconductor of a scarce material will be difficult to put into global use, right? And finally, the cost. It's important that if it's so that it can carry out all the aforementioned application, it's cheap to be able to use it as a raw material. That's why this type of research and advances are made to be able to overcome these challenges and to be able, in the future, to use these materials.
In summary, we can affirm that the discovery of the first superconductor that operates at room temperature is something revolutionary due to its great potential applications, but also the huge amount of energy that wouldn't be wasted if it's possible to produce a material that is stable or metastable without the use of high pressures. However, this discovery is a big step closer to the long-loved goal, that is, create electrical systems with perfect efficiency, which will transform the world's energy grids, computation, and transportation systems entirely. And that's all for us. We hope you liked the presentation. Thank you so much for your attention.